Hi, welcome back. This is Bitcoin in 30 minutes. And today we're going to be talking about the fundamentals of Bitcoin. I'm not going to go over some of the historical aspects as to why Bitcoin was created or invented, and you can research that on your own. But what I do want to talk about is some of the fundamentals of how it works. Now, I'm not a software coder, nor am I an engineer. I am a lawyer by training, and I've been a tech curious enthusiast since 2015. And Bitcoin has been on my radar since law school in 2011. I've seen several documentaries on Bitcoin since 2011, but like many, I dismissed it as something that was fringe, not viable, and all of that. It wasn't until 2018 that I saw the light, so to speak. So, I want to talk a little bit about the fundamentals of what's going on here. What you do is you have and what I try to do is explain these little memos in 30-minute increments in a way that everyone can understand them. So, what Bitcoin is, it is digital, non physical units of account. And when I say units of account, I mean that there are 20 it's open source software in the sense that it's computer code, okay? And the computer code keeps track of 21 million whole bitcoins, and that is kind of the base of how many bitcoins that will ever be created, 21 million. And the computer code keeps track of other things as well, many other things. Specifically, the computer code keeps track of how many bitcoins are issued about every 10 minutes. The issuance of Bitcoin literally comes from computers that are competing to solve a random mathematical problem. Okay, so let's say you have three computers A, B, and C. And then you have some other user, Bitcoin user one, Bitcoin user two, and Bitcoin user one wants to send some Bitcoin to Bitcoin user two. What happens is the three computers will compete for the privilege and the opportunity to confirm that transaction on the global Bitcoin blockchain ledger, the accounting ledger. And they do so through competing through through the ability to solve the math problem. Some of them get it wrong, and then one lucky computer will get it correct. That lucky computer that gets it correct, or computers, if it's part of a larger group of computers competing together, will be awarded bitcoins. And about every 10 minutes, the bitcoins will be issued. It's 6.25 bitcoins today. And in 2024, that issuance will revert back. It will go down to 3 point something. So it basically halves. So I think it's 3.12 or something like that, 3.125 or something like that. So that's how the bitcoins are created. It's a process called mining, quote unquote, mining, and it is larger in a larger aspect, a theory, not really a theory, but it's a concept called proof of work. The idea here is that, let's say Bitcoin computer number four, or mining computer number four wants to participate in the mining process. That mining computer number four must consume energy and consume capital investment. When I say capital investment, I mean investing in buying and producing energy and computing power to participate in the mining process. all of that requires work. It requires investments of money. It requires risk. It requires a certain conviction that the process overall, that the business opportunity overall will be profitable. And it is that work that makes Bitcoin, partly, it is that work that makes Bitcoin have any value whatsoever. So let's kind of analogize Bitcoin mining to diamonds, the production of diamonds. Diamonds are like, let's assume that diamonds are totally worthless today. So you go in the ground, you see this rock, it's pretty, but nobody cares about it because there's a million other beautiful rocks in the ground, right? And they're not scarce. Yeah, they're pretty, but everybody has them, and so nobody cares, and they're worth like almost zero because you can just go and pick up a diamond from the ground, right? Just hypothetically. The work that you put into produce a diamond is pretty much worthless. It's worthless because everybody can get one if they just kind of bent over and picked one up from the ground, right? Like, let's say it's a world of diamonds, right? The scarcity of the diamond is not scarce at all. They're plentiful of diamonds. So analogize what's going on with the diamond hypothetical to the Bitcoin hypothetical, which is there's only 21 million Bitcoins, and the open sourced software code that establishes this principal framework or this principled foundational rule makes the creation of Bitcoin scarce. The production rate for a Bitcoin every 10 minutes is also fixed. The software basically says that only today 6.25 Bitcoins will be created every 10 minutes. The transactions, as far as who is moving what Bitcoin to what address and all of that, that is also, that part is not fixed. It is simply the supply, the total supply of Bitcoins is fixed, both at the rate level and also at the foundational principle level. So 21 million cap and the issuance rate of 6.25, which according to the open source software is going to be 50% halved in 2024. I think it's like March or April 2024, which will revert down to 3.125 or something like that. That's important because the demand for this finite scarce asset is expected to go up. And I don't mean up like a little bit. I mean a demand signal in terms of people, governments, nation states, institutions, hedge funds, legal entities. We expect them, or it is expected, that they will allocate and purchase some Bitcoin. They already are today, but we expect that the demand signal to be increased substantially by 2024. At the same time that the issuance rate is reverting 50% down to 3.125 per 10 minutes. And at the same time that the hard cap remains as is, which is 21 million Bitcoins that can ever be created. Okay, so let's kind of talk a little bit about how many Bitcoins have been created so far. So the estimation is about 19 million or something like that. So we're most of the Bitcoins have already been mined, right? Now, some Bitcoins have been lost. And when I say lost, I mean that once you have Bitcoins in your digital wallet, which is basically a series of numbers and letters that's open, it's pretty much like an address. kind of like a street address, so to speak. It's public, it's open. People can see, that the digital wallet exists. They can see how big, i.e., how large that building is, how many Bitcoins are in that wallet. It's very similar to analogizing the Bitcoin digital wallets as buildings and streets, whether something's really tiny, like a little house, or something's like a big monstrous mansion, or something's like like a Sears Tower in Chicago or something. But you can see it. People can see, obviously, they can't see the owner, whether it's an entity or whether it's a person of the digital wallet, but they can certainly see the wallet itself. Now, and this is public information. You can go on the website and look at the various different Bitcoin, what they call block explorers. Type in the public address, and you can see how many Bitcoins are contained within that digital wallet. Now, going back to the loss of Bitcoins. When I say loss of Bitcoins, I don't mean that the Bitcoins have dissolved or the Bitcoins have been canceled or that the Bitcoins have been redlined and the network's going to refuse them. That's not what I mean. What I mean is that the Bitcoin wallet, it is presumed, just based on public information, that the means to move and extract those Bitcoins from that digital wallet is eliminated. And what I mean by that is when a digital wallet is created, it comes with a public key, which is the public address I just spoke about, and a private decryption key. So the private key is very similar to your home key. But it's a home key on steroids because you can't just go to the Home Depot and replicate it. It is a series of digital numbers and letters, and it must remain private in the sense that it is a random series. I think it's like 16 letters and numbers that are completely and totally unique to that public address. So I'll say that again because this is a really important point for you to understand. You have a public address and you have a private key that is completely unique and associated with that public address. And what the private key does, it unlocks the public address and allows the public address to be able to move Bitcoins from Bitcoin wallet A to Bitcoin wallet B. And without that private key, you're not going to be able to ever move your Bitcoins, period. Without that private key, there's no way that any third party that doesn't have that key can move the Bitcoins. And so when I say that those Bitcoins, there's I don't know how many millions of Bitcoins that are quote unquote lost. What I really mean to say is that the means to move those Bitcoins have been eliminated because the person has passed away and the private keys cannot be found. We've encountered situations where, when I say we, I mean this industry has encountered situations where there's a hard drive and, it's in a landfill and the private keys are on the hard drive and the hard drive cannot be found. We have folks who have just, reformatted their computer and the private keys cannot be found. And so the means to move Bitcoins from point A to point B, wallet A to wallet B, is solely and exclusively dependent on the ability to retain private keys and to enter those private keys into the Bitcoin wallet and then move the Bitcoins. So this is a good thing, but it's also a risk. The good thing is that it's highly secure. It would take it goes around the internet that it would take the world's most powerful supercomputer to date. Obviously not a quantum computer, but a supercomputer. I don't know, 100 or 250 years to try to randomly guess the private key to move a Bitcoin wallet. In other words, the computational power that's needed to guess the private key is just so immense that it's impossible, basically. And so this is this is an important principle for you to understand because um, this is simple math, right? So this is math. I mean, it's not like you go to the bank and the cash is in there and it's in a vault. It's in a material, in the material physical world, that's a vault. And, you need like a lot of tools, maybe even some, combustion to like open the vault and get the gold out. This is totally different. This is a digital vault of sorts. And so what you do is you have a digital vault backed up by encryption power, the power of encryption technology that is preserving and holding the security of the bitcoins in the wallet. So, and the only person that has the key, the private key to open those bitcoins and to move them is the private wallet, is the wallet holder. So when you create the wallet is created spontaneously with a public and a private key. And so that's kind of how you get the public and private key. And so I think it was like the Gemini twins that they have so much Bitcoin that their private keys are divided amongst them two, plus, a third party. And so there's this idea that, in order to preserve and not lose your private keys, therefore losing your Bitcoin, one way is to kind of share your private keys with, a relative, or share a part of the private key to a third party. Or what I do is I have my private keys further encrypted into words. And so the idea is like there's like a kind of like a little dictionary of sorts where you can like move the words around and the words translate to numbers and letters, and then that's how your private key exists. So that's kind of what I do. But the idea is that you do not want your private keys to be inadvertently disclosed or inadvertently lost, because that would cause a complete loss of your bitcoins. So high risk there. I wouldn't even say it's high risk. I would say it's medium risk. If you're not responsible enough to hold bitcoins, you may want somebody else to hold them for you. So decentralization. I want to talk a little bit about the decentralized nature of Bitcoin. I don't mean decentralized by who's mining the Bitcoin. I mean decentralized by way of how the software works. It's been said, and like I said initially, I'm not a software developer, but I've done a lot of research and I've heard a lot of different software developers talk about how, in order to change the Bitcoin code, you have to have what they call consensus or agreement among 51% of the miners. So I'll say that again because it's kind of weird. So no single miner or single entity can change the open source Bitcoin software. The only way to change the open source Bitcoin software is by getting 51% agreement by all the miners that are currently mining Bitcoin. So I think what they call this is a hard fork, is what they call. The idea is like you have the blockchain, and everyone's participating and mining Bitcoin, and this is the Bitcoin protocol, and this is the open source software that they're mining and they're producing Bitcoins from. And then someone proposes a change. Hey, instead of doing things this way, let's do things that way. And these are called Bitcoin improvement projects or proposals, I think it's called, BIPs. But the idea is like the open source software code can be changed, but you got to have 51% agreement in order to change it. Mostly everybody, I would say there's an extreme minority of people are on board with changing the fundamentals, which is 21 million Bitcoin cap. The idea there is that the entire fundamental of Bitcoin is to be hard, ultra mathematically hard money. The idea here is that you can't create any more of them. It's a finite cap. Unlike gold, where you can go and mine for more gold and destroy more mountains, or unlike diamonds where, you can get $1 billion worth of diamonds and hide them in a vault and then control the supply and then go mine and destroy more ground for more diamonds. You can't do that with Bitcoin. In order to do that, you'd have to get 51% miner agreement to any kind of change on the Bitcoin code. There's another interesting example. It's called the memory. So when you do a Bitcoin transaction from Bitcoin wallet A to Bitcoin wallet B, it goes into what they call a memory pool. And the idea there is it's kind of like a waiting room. It's like a queue where it's your transactions, basically queued up or lined up to be mined and confirmed by the miners. There was a proposal to increase the amount of data and amount of transactions that can be, like, I guess, stored in the waiting room. This is called the memory pool. From 1 megabyte, which is a certain data number, to I think it was like 5 or 10 megabytes. And then, moreover, to increase the Bitcoin blocks on the Bitcoin blockchains from 1 megabyte to, I forget, it was like 2 megabytes or something like that. So, and that would be a fundamental shift into the fundamental workings of how Bitcoin is recorded onto the Bitcoin blockchain. So that was rejected by 51% of the miners. There was a huge, this is called the block size war, or whatever. There's all these different names that the Bitcoiners, try to give these things. And it was rejected. And the idea here is that, there's scrutiny, very similar to the democratic process, where there's criticism, there's pros and cons, and then folks just vote with, their mining capacity. Say, okay, I'm gonna agree to that and start mining that proposal, and then others say, no, we're not going to do that. We're going to do this instead. We're going to stay with the traditional Bitcoin the way it is right now. And so that failed. The block size battle has failed. So there's Bitcoin. I think it was in 2018, where the miners and the participants into the Bitcoin network were just like, no, we're not going to do that. This is the Bitcoin. It is what it is. It's 1 megabyte, and that's just the way it is. And so that's what we have today, because the proposal did not win. But it's interesting because that is a very decentralized way of doing business. When our central bank today wants to create money, they just create it. When the Congress wants to issue more debt, they just issue it. Now, some will say that Congress is a representation of the United States democratic process. I would disagree with that. There's not a 51% direct democratic process in the United States. I don't want to get too political or get into the functions of government, but I will say that the Bitcoin mining process is much more directly democratic than anything that we have today on this planet, with respect to governance of money specifically. Now, obviously, if you have something that's like, a little organization and you're voting and things like that's democratic, whatever. But what I mean about the functions of money today in 2023, Bitcoin and its open source decentralized democratic process of 51% consensus, i.e. agreement, is the most democratic form of money that we have in existence today. That's important because it gives me personally some assurance that it can't just change at the whims of a politician. It can't just change at the whims of geopolitical environments. It can't just change at the whims of supply and demand. It is what it is based on those who are actually participating in the network and have scrutinized the proposal, the Bitcoin improvement proposal, and have determined that this is the right course of action for Bitcoin. Well, we have 5 minutes remaining on the Bitcoin in 30 minutes, this iteration of the Bitcoin in 30 minutes. These are the fundamentals, in my opinion, of Bitcoin. There are many other fundamentals, I'm sure. If there are additional fundamentals, what I'll do is add them to an additional Bitcoin in 30 minutes audio. We have 4 minutes. Let's see. So we talked about mining. We talked about the 120 movement. We talked about public-private addresses. We talked about decentralization. Why does Bitcoin have value? I think I'm going to reserve that one for a different one because I could probably talk about that for a while. Space time. So I think what's really interesting to talk about with Bitcoin is that it basically what they call dematerializes space, in the sense that, and what I mean dematerial is that it moves money transactions from the physical domain to the digital domain. I think that's pretty fundamental. So, for example, I always like to give the folks examples. If I'm in New York and I want to send Bitcoin to my relative in Puerto Rico, there's no bank or government that can stop me from doing it, because it's totally decentralized in the digital domain. But moreover, I do not have to travel to Puerto Rico to do so. I just get the public address from my Puerto Rican relative. I take my computer, ensure they have their computer, and I send the Bitcoin. It goes to the mining network, and they have it, I don't know, within 10, 11 minutes, something like that. It could be seconds. I mean, it could happen instantaneously, but the confirmations on the Bitcoin mining network could take a little bit longer. And then the cost to send it has nothing to do with any kind of third party that wants 15%, 10% of the transaction value, which we call rent seekers. It happens pretty much for free. I mean, maybe 10 cents, depending on which mining and confirmation mechanism and software iteration you're using for Bitcoin. They're different iterations that allow you to send it. And so yeah, it you don't need to have all these barriers to sending money throughout the world. As long as the other person has an internet connection, you have an internet connection, it happens instantaneously for a nominal cost just to mine the Bitcoins. So in that way, it dematerializes and it makes irrelevant the physical barriers, the government barriers, the institutional barriers, the cost barriers of fluid digital money throughout the planet. This is groundbreaking. It's very fundamental to Bitcoin, as a open source decentralized money. But it's something that a lot of folks either aren't fully recognizing or aren't fully pricing in to the value of Bitcoin. There are all sorts of natural catastrophes, political catastrophes, things that would cause a person in a certain country to want to send Bitcoins to another person in a different country and do so instantaneously without barriers. That's huge. And in such a way, you can move your wealth around and keep it on an indefinite blockchain, for time, for throughout the passage of time. And in that way, Bitcoin is a time preserver. It is a time efficient tool to preserve the money, but also move the money. The money being Bitcoins. Anyway, so a couple things to think about on this Bitcoin for 30 minutes, Bitcoin in 30 minutes audio. I hope you enjoyed it, and I hope you listen. If you didn't understand any of the concepts, I hope you Listen to it again and again and again until you do understand them. I encourage you to research and use your tools such as Google or ChatGPT to research and to fundamentally understand the basics of Bitcoin. Have a nice day.